Hi, and welcome to our 94th test and measurement video. Today we'll look at what seems to be a simple and modest oscilloscope control, but actually it accesses quite a multiplicity of functions that are basic to all oscilloscopes. It is the channel button, one for each channel. In the Tektronix MDO3104, there are 4 channels and 4 buttons, each in its dedicated channel color. When you power up the oscilloscope, by default, only channel 1 is on. Its button is the only one that's lit up. Pressing that button, the channel menu appears across the bottom of the screen. Incidentally, any combination or all of the channels can be turned on. For example, now channel 1 and 4 are on. If a channel is off, any signal at the input does not get sampled and does not get to the processor. So now, pressing the channel 1 button again, we bring up the channel menu. The first menu item is coupling. This is common to all oscilloscopes. DC coupling, the default setting, is used most of the time, but the user has the option of pressing AC coupling. This eliminates the DC component in the display and changes the scale accordingly, so that AC ripple can be measured in the high-level output of a DC power supply. The next menu item, moving to the right, is termination, which, by setting the associated soft key, can be set at 1 megohm or 50 ohms. The default is 1 megohm, which is used almost always because it places very little load on the circuit under test. 50 ohms is useful when it is necessary to match impedance for maximum power transfer in some low impedance or high frequency circuits. The next menu item, which can be toggled on or off, is invert. This control reverses the polarity of the waveform. Using the internal AFG output fed into channel 1, this is what it looks like. If normal and inverted zero offset sine waves are added using the math mode, the result would be a flat zero amplitude trace. Bandwidth permits the user to reduce the bandwidth from 1 gigahertz to either 250 megahertz or 20 megahertz. The purpose is to eliminate noise from the signal, to clean it up. To demonstrate, we'll turn AFG on so that the sine wave in channel 1 is displayed. Then, press output settings and add 30% noise. Notice how the same sine wave signal is obscured, even to the point where triggering is lost. Returning to the channel menu, if we limit bandwidth to 250 megahertz, the signal is a little better. And when we limit it to 20 megahertz, there is a dramatic improvement and triggering is restored. Bandwidth limiting works because noise is a very high frequency phenomenon that is greatly reduced as the analog frequency response is cut, while the signal being studied is affected to a lesser extent. Pressing the soft key associated with more, a vertical submenu appears above that key. The top menu item is Fine Scale. This refers to the amplitude in volts of the signal relative to one division in the vertical scale. It can be set by turning multipurpose knob A or by entering a value in the numeric keypad. The range is 10 volts per division, which produces a flat horizontal trace that lies along the x-axis, to 1 millivolt per division, producing spikes in the display. It is to be emphasized that what is being changed here is volts per division in the grid, not amplitude in volts in the signal, which, if you press AFG and look at the information bar, is unchanged throughout at 500 millivolts peak to peak. Similarly, offset and vertical position can be set by turning multipurpose knob A or by entering values in the keypad, and they can be reset to 0 by pressing the appropriate soft key. Scrolling down, probe type can be toggled to voltage or current, and probe attenuation can be set from 1000 to 0.001 by turning multipurpose knob A or entering values. Thanks for watching. New videos are added periodically, so check back frequently.